Hello, this is Mackenzie Crouch, and I just want to go over some of the features that I put into the game called GOAT. To start off, I will tell you about the spline collisions that I created. So in this game, this hot air balloon goes up and has to run into collisions of cliffs. So I created these cliffs from a spline, which I then added points onto, also following the layout of the art. I also created the goats, which you see throughout the mountains. So here we have a goat with a sphere collision. I also created the birds, which you see throughout the level, and I used a capsule collision. Both the bird and goat are sprites. Here is the starting screen for the level. Inside the game I can better show you what I did with the hot air balloon. So when the character is down and not moving, has no velocity, his arm is down, but as soon as he starts moving, his arm goes up. Now we have a lasso mechanism to catch the goats. And so if I go over here, the goat with the spherical collision can be caught with the lasso if I hit that. And then I have a cable basically attached to the goat that helps him stay along with me. Now you see that my balloon is damaged. The birds in this level can damage me. Now if I get hit 3 times, the game will be over. So I'll demonstrate the second hit of damage and wait for the bird to get back. So as soon as a bird hits me, I get another damage. Now I can keep collecting goats along the way. I can change my direction. As long as my lasso hits that goat, I can attach to it. And as soon as I hit that last bird, it goes to the end screen. This is the spline blueprint for the cliffs collision within the level. We start off with the spline and get the number of points subtracted by 2. Then go into a for loop, which we create the start and end points. So the start points and the end points, which have a +1. And then we add a spline mesh component and set the static mesh and give it its own variable, which we could set within the level itself, along with the material and the forward axis, which can be set outside in the level. Then we attach that to the component, basically giving the spline that static mesh, and we set the start and end points from our set location or get location and get tangent from down here. Then the very last is setting the query only no physics collision. The bird, which I showed in the level, is basically comprised of a sprite flipbook and a capsule collision. Now in the event graph, we start off basically by playing the game and then delaying the bird if we want, based on expose on spawn variable. Then we set the initial location to whatever the original location of the world was when we put it in the level, and set the rotation so the bird is facing the right direction. Now from that set initial location, we add 5,000 in the X so it travels to the right, and set a new location based on that addition. Now, to check whether it is in between the left side and the right side boundaries, we check against the get world location and check based on whether it's less than the new location or greater than the initial location, and add that move speed, which we set to 20 in this case. Then we make sure both of those are true, and if they are true, we're going to set the world location, which is basically the capsule's location plus the move speed. That way we can move the bird left and right. Now it will only start to move left after we've begun the game once you hit 1 false, which will multiply the move speed times -1. This false happens when it's about to go outside these boundaries. After that, we get the world rotation, and if the world rotation is 180, it's going to the right, but if we hit that false and we have to set the move speed to -1, we want the bird to move to the left and be facing the left. So we set the world rotation back to a -180 degrees. The hot air balloon basically works by attaching a basket to the character, basically following it wherever it goes, and then a attachment which attaches a goat to the basket object that's following the character. So here we have the blueprint for the basket, which is basically just getting wherever that scene location is within the character and setting that actor's world location to it. For the character, we can see the scene here is out front, so that way it doesn't interfere with the capsule collision. Here we have the blueprint for the attachment, which is basically 2 spheres, a cable, and some physics constraints. Now, sphere A will attach to the basket and sphere B to the goat itself and have that physics on it so the goat falls downward. The cable is then following along between the two and staying in one segment because that's what I have it set to. And then we have a physics constraint to how far that can go. Now, for the event graph, we have an attached to reference, which is basically finding BP basket in the level and calling that static mesh's world location. Then we will set sphere A's world location to that, basically attaching sphere A to the basket. We set the constraint components, so sphere A as our component 1 and physics constraint A as the target. And then for our attached to ref static mesh, we're going to make that our component 2 and get an attached socket name for bone name 2. Now to set the world location of B, we're going to use an attach point, which is basically going to be when we hit the goat, it calculates a new location where that goat was been. And then we're going to set the scale, so whatever the scale of the goat was, whether it was facing left or right, we're going to get that direction and change it to that. Back to the character, we have a capsule collision around the whole sprite flipbook itself. Of course, I showed earlier we have our scene out here where the basket is following. And then we have this collision sphere off to the right, which is actually the end of our lasso. So when the lasso sprite plays, it ends up here, and that's where our collision is going to appear when our lasso hits there after a certain time. This is what determines whether we hit the goat or not. Now into the event graph, there may seem to be a lot, but it's not too complicated once you get into it. First off, I set the character movement to flying, so the hot air balloon is flying immediately once you start the level. I added my own axis movement, which is move up and down, based on the WASD keys. And then we have our axis for moving right, and then setting a relative rotation to that sprite. So basically, if we're going right, the character's facing right, left, facing left. Now, for the goat itself, once we overlap that sphere, the sphere on the character itself, if we hit the goat, we're basically saying to get the scene root, its location, and make that our attach point. So that's where we're going to attach sphere B. Now we're also getting the paper flipbook from that and getting the scale so we know which direction the goat is facing and which direction we need to spawn the new facing goat. We also have our basket reference, which we're getting that action transform here, and our attached to ref is basically based off this basket ref. Now we're also taking the cast to the BP goat and destroying the goat after we spawn sphere B. And as soon as we catch the goat, we are also playing the goat screen. For the bird, when the bird hits the character, we're basically adding a damage level, and that damage level will be set and then destroying the bird. Here we also have a lassoing check to see if the character is going through the lasso sprite. We wait 0.7 seconds for that sprite to happen, and once that does, we set the sphere collision for the character itself to actually be enabled, so we can actually hit the goat. And then when we're finished, we're going to set that collision to the sphere to none, and it is lassoing to none. To update the animation, we're basically going to check via event tick, and we're going to see if it has any velocity. If it does, we're going to say it's moving, and then we're going to get the rotation of the controller and change that based on if it's moving or not to get it to go left or right. Now we also check to see if the damage level is 3, because if the damage level is 3, we need to create the end screen widget. We're saying the game is over. This is the largest part of the character's code, but it's a lot of repeated stuff. To go over it, we'll basically check if update animation is happening, And if it is lassoing, this is the largest part of the character blueprint. It's a lot of repeated stuff, so I'll go through one of each. Now, we're checking to see if update animation is happening, and if it is not lassoing, we're going to check the damage levels, which can be 0, 1, and 2. Basically, we're going to check if any velocity is happening. If it is, the pilot's arm will be up. If not, it will be down. And depending on the damage level, it will be different pairs of sprites. And then we're going to set those sprite flipbooks and make sure set looping is off. Now, for update animation, if we are lassoing, we are again going to check which damage level it is, and we're going to get the flipbook that it is. So it's either lasso, lasso damage 1, or lasso damage 2. And if that condition is false, we're going to set the flipbook to its new required flipbook and set looping to false, along with playing that sprite from the start to make sure it doesn't start from the end or from the middle. Thank you for watching. Goodbye.